Hello, today's lesson is going to be on what are called piecewise functions. We're going to spend a couple of days on this topic, so we're going to start off with the basics. What is it? So first off, it's a graph where the function is broken up into smaller pieces. And here's an example of what it looks like. So we've got this f of x, so there's our function, and it's got two completely different responses. So first off, if the x is less than 1, then the f function graph is at 2. That's a horizontal line at 2. So everything from x is 1 to the left forever is a flat line at 2. And we put an open circle at that spot because of this symbol, just plain old less than. All right, the equal to 1 comes from over here. So if f is equal to 1 or greater, then it's going to follow this pattern. It's a line with an intercept at -1 and a slope of up 1 over 1, up 1 over 1, up 1 over 1. So again, we get this diagonal line, but it doesn't start until we're at x equals 1 here. And then it starts. It doesn't go, this part back here is not part of the answer, because everything where x is less than 1 has a different answer. Now you might be thinking to yourself, who on earth would ever use any of this stuff? And honestly, this stuff's really useful, a piecewise function. It would be, for example, how the post office charges for packages. If you order something off Amazon, for example, if it's less than £1, it is, like $3, or if it's between £1 and £2, and the price goes up to $4, or if it's between. So again, as the weight of the package changes, the price changes, and it kind of moves up in pieces. So again, this is actually pretty common in the real world outside of a high school class. So something that's definitely worth our time looking at. All right, so what's today's work going to look like? All right, for today, you're going to be evaluating a piecewise function, which means you're going to be given the actual function and all of its values, and then you're going to find some specific answers. So we'll start off here with this first problem. We'll call it number 1. And it says, find the value of the function when x equals 1. Well, the first thing we need to do is decide which one of these do we use. So if x equals 1, well, 1 would fall in this category. 1 is less than 2. Which means for that problem, I'm going to use this one. 3x, which has been replaced with 1. That's what this means. Replace x with 1. But we need to know which part of the equation are we at. Which piecewise, or piece of the function are we looking at? So if I do that, 3 times 1, that's 4. And then plus 1, well, the answer is 5. Well, the second one, we're trying to now find the value of the function at 7. Well, 7 is greater than 2, which means we need to use this particular equation, -2x minus 4. And again, this time we've plugged a 7 in for the x. Well, -2 times 7 is -14, and then minus 4 is -18. So again, we're just trying to get used to how these look and trying to understand that there are multiple different equations to use depending on the value of x. Again, in this one, if x was less than 2, we had to use that one I circled in blue up there, 3x plus 1. But if x was greater than or equal to 2, then we had to use the one I circled in green, -2x minus 4. All right, so again, we're going to work on this all week, so it's okay if you don't feel like an expert at this point. But hopefully you're able to at least do some of these evaluate problems, which aren't too terribly difficult. All right, good luck.